This is an example where I show you how to handle missing or null values when you load data into a Pandas data frame in Python. So this is my data set. It's from a bank's marketing data set. You can see it has about 40,576 rows, and in this there are some values where age or contact information or duration of business is a missing value. Here is also, for example. Okay. This data set had a lot of other columns: account balance, loan balance, credit score. Those columns are not relevant to this demo, so I've eliminated those columns, but I still have 40,576 rows. So it's a fairly large data set. So I'll just close this file. So I'm going to start first importing pandas as PD. Now by convention we always use the alias PD for pandas. Then I load this file. I view the top 5 rows. Now you can see the first row, for example, when we were just viewing earlier, had a 0 as a missing age, correct? So it appears as a nan, not a number. Contact, the first row contact also was missing, so that also appears as a nan. And the fifth row here, duration was missing, so that also appears as a nan. Now in your data frames, any missing values will not appear as null, they will appear as nan. So in other languages you may see them as nulls. Here you will always appear as nans, whether they are strings like contact or whether they are numbers like age and duration. Okay, so now let's look at the shape of this data frame. 40,576 rows with 6 columns, which is correct. The 0, 1, 2, 3, 4 are the indexes, and these are the columns. Let's look at information about the columns. So again, we know that the total number of rows is 40,576, but 40,576 rows have non-null value in age, meaning 2 rows have a null age. Similarly, there are some rows where contact is null, like 6 contact rows are null, and 4 contact rows are null. 6 contact rows are null. I keep missing this. And 2 plus 6, 8 duration rows are null. So let's find out how many rows are actually nulls. The number of rows of age is null is 2, number of rows where contact is null is 6, and where duration is null is 8. Okay. Now in other languages you could use the is null function or is null operator, but in Python when you're using checking for nulls or nans, is na is what is used. It is an alias for is null, so it doesn't matter. By convention we always use is na, we don't use is null. Now we want to find out which are the rows where the values are actually null, so we can write a query. Now each of these elements of this query will return true or false only. It doesn't return the values or the index ID, it just shows true or false. So which rows have age missing or contact missing or duration. This pipe is because these are bitwise operators, true or false, true or false, true or false, to a bitwise or of all of them. So I find out list all the rows where any of these values is a null. Okay. So what I get is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. This is about 11 rows, not 2 plus 6 plus 8. 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So for the first row, age is also missing, and contact is also missing. For the second row, duration is missing. There are other rows where duration and contact both are missing, like these 2 rows. Okay. Then there is this row where again age, contact and duration are all missing. So these are all overlaps. So there are actually 11 rows where null values exist, not 2 plus 6 plus 8. So one method of handling nulls is, if you have only 11 rows with missing values out of 40,500, maybe it is safe to drop those 11 rows. Your data set is not reduced by a significant percentage. But if there were maybe 200 rows and you're dropping 11 rows, then you're dropping 5.5% of your data, which may not be good. But 11 out of 40,576 is okay to drop. So let's just drop those rows. Now let's look at the 565. So it was 576 rows. Now it is down to 40,565 rows, which is correct. 11 rows have been removed from the data frame. This is in memory. We are not removing them from the CSV file. We loaded the CSV file into memory as a DF data frame. Let's just check again. 40,566 rows, 40,565, sorry, 565 index values. All of them are null values. So we have removed all the nulls. I do a count. Yep, the count doesn't return anything. If I were to run this query also, for example, it would not return anything. Let's just try to run that query again here. Create a new cell and run it. Okay, so it returns an empty data frame. For these columns, there is nothing where age is null or contact is null or duration is null. So this is one array. There were 11 rows with either one of these or both of these or all three of these columns having null values. We just remove them using drop NA. Now another method you can use is to replace the values. So you don't want to drop all the values. Maybe if you had only 200 rows, you wanted to replace the values. You don't want to drop 11 rows out of 200 rows. You want to replace the nulls with some representative values. So let's do that again. I'm reading the data set into a new data frame called df2. I see the same data set. Now I know there are rows where age is null, correct? So I will say I want to replace the null or missing age values with the median age value. So first I compute the median age, which is 38. Now remember, this is seen as a floating point, so we always see 38.0. Now this is the syntax we've been using for some time. Take the data frame, take the age column, fill all the null or missing values with the median age and do the replacement in place. This syntax is what is normally being used, but when you run this command, it does run, but you get a warning. Okay. It says this behavior will change in Pandas 3.0 and this in place method will never work. So when you go to Pandas 3.0, this syntax will not work. So this is a very good feature of Python. You will get warnings saying, okay, in a future version this will not work. You better start changing your code. So these are some alternate methods it's suggesting. Instead of using this current syntax, I could use this syntax, or I could use this syntax. Okay. For the present, this warning says it has run what I have specified. This column is what I specified. This is what it has run. But okay, I want to rewrite my code. I want to use what will be supported in Pandas 3.0. So let me just check my version. I'm running 2.2.3. I look up the documentation for fill NA. It says the current stable version is 2.3 and I'm on 2.2.3, which is not too far away. The next version, higher version, will be a development version. So I'm not running a development version. I'm actually running 2.2.3 and 2.3 is also stable. But this change will appear in 3.0. So let me start using the new code. So I can just reload the file. I could have gone back to a previous cell, but I would be scrolling back and forth to reload the file. I could have gone back to say read the file again here in cell number 12, but let's not do that. I will just reload the file here in cell number 17. Verify that I have the same 5 rows. Yes, I can see this nan, this nan. So that means I have not overwritten the CSV file. I still have the same CSV file. And now I run the same query again for df2. Remember, this new load is df2. Okay, and these are all the rows where nulls or missing values which are shown as nans. Now I decide I am going to anyway compute median. Let me just look at the max and min ages as well, so I can do that. I get the max age is 65, the min age is 17 and the median is 38, so that is fairly representative. 38 is a median between 17 and 65, so that is fine. So now I use the new code. So if you look at the warning, it says you can use either this syntax or this syntax, right? So I'm using the new syntax here for fill NA. If I run this, I get no error messages. Okay. Now I look for rows with missing age. Okay, so now all the rows with age have no missing values. I did not drop the rows. Remember, in this second, in df2, I did not do a drop. I just did a fill any. Any row with the missing age is replaced with the median age. So that's fine. I have looked at the age. I also have contact and duration with missing values. So duration is again a numeric. So again I look at min, max and average duration instead of median duration. So min is 1, max is 4918 and average is 258. So for duration I want to replace with the average duration. So this is my code again with the new syntax that will be supported, only supported from that will work now onwards and is the recommended for Pandas 3.0. So I do a fill any. I check that there are no rows with duration missing. Okay, so duration is also full. Now for contact, if I look at the data, contact could be cellular or telephone, or it could be something else. Let me just check what are the different value counts in contacts. Okay, so I have two different types of contacts, cellular and telephone. Okay, so value counts is actually just a count, so that's why it says data type. These counts, what it has returned is this is the index cellular and this is the value. This is an index and this is a value. So the values are integer. So I want to first say, okay, I want to replace the missing contact with the most common contact. So what is the most common contact? I can actually use mode, although contact is not a number. Normally you would know that mode is only used with numeric data types. The most frequently appearing number is a mode. But I can also say that the most frequently string is also the mode for that set of data. So if I get the most common contact. Now you can see here when I print most common contact, what I get is an object data type. Okay, not an integer data type or a string data type. It's an object data type. So essentially what is this object data type consists of all of this: 0, cellular, name, contact. All of this information is in the object data type. So if I want to get only the word cellular, I have to take element 0. Element 0 is the word cellular. So I replace the contact values with element 0 of most common contact, and now I check for value counts. So now you can see from 25593 I'm gone up to 25599, which is 6 contacts have been replaced. And now I see there are no nulls, and I want to verify that nothing got dropped. So 40,576 is still the same number of rows, but whatever were missing values in this data set, okay, whether they were in age or in contact or duration, have all been replaced by median age or by average duration or by the most common contact. So we come back to this situation. If you have a data set where you have missing values, you have two options. You either do a drop any, and if the number of rows being dropped is not significant, it is fine. But if the number of rows being dropped is say 11 out of 200, it is too many rows to drop, you use the other method. You use fill any method. So this is how we do a fill any for age using the median age, for duration using the average duration, and for contact, which is a string, I take the most common contact element 0 because this is an object data type, and I replace the contact with the most common contact, and that I end up with a data set of the same size, same number of rows without any missing values. Thank you.